All right, this is week 3 of pre-calculus, and we're going to look at quizzes 1 and 2 for composite and inverse functions, quizzes 1 and 2 for trig functions. So let's do this. I actually took this quiz one time. All right, so let's go. The graph of y equals f of x is a transformation of the graph of y of h of x. So f of x is the transformation of h of x. Given that h of x equals negative x minus 1 squared minus 1, write an expression for f of x. Okay, so we see h of x, and now the question is, what's the difference from f of x? So what I see is so I'm looking for two things, the shifting, and we should remember vertex form, a x minus h squared plus k, where yes, h and k are the vertex, but they also show the horizontal and vertical shifting, right? So the horizontal shifted h and the vertical shifted k. So, and then the a is the it's like the size change, right? The dilation. So if the graph gets skinnier or wider or whatever. So let's see, first of all, that it's shifted up, right? We're going up by how many? 1, 2, 3, 4, 5, 6. Up 6. Okay, so we see that. That means we're going to have to add 6 to the y coordinate, which is currently -1. Which will make that a +5. So with that analysis alone, that's what I'm thinking the answer is. But I want to check one more thing. I want to check that the size change did not happen. So if I go over 1, I go down 1. Did that happen on the new one? Over 1, down 1. Yep. So it's only a vertical shift. So let's go ahead and put that in. Negative x minus 1 squared plus 5. Look at that, we got it. All right. Now, function g is scaled vertically. Okay. So now we can scale the function in two ways, vertically and horizontally. So it all depends on where are you making the change. So the vertical change is like, the vertical change would be multiplying the whole rule by a number. The horizontal change would be when you multiply the independent variable by a number. So right here, I see a vertical. So function g is scaled a function of f. So we're scaling. So we get 416, right? And then we're going to 4. So what's happening to that y value? It is being divided by 4. And it's a vertical. So that means that there should be a 1/4 outside of f of x. So let's see what, here it is. Okay, let's try this. We got it. All right, so let's look. We're just looking for that. G is a transformation of f. What is G? Where is f? Oh, G is red. F is blue. So G is the transformation of f. And okay, so you can figure that. Well, all right, I'll do it. So we're shifting down, so we want to see outside. Where's the vertex? 1, 2, 3. Shifting down. Oh, this is very interesting. So first of all, it's reflected, and then it's shifted up and left. So I think I can do that. Oh, that's interesting. Okay, So I mean, I could argue that it is what I said, but now looking at the choices given, it's reflected over both axes. It's reflected over the x-axis and it's reflected over the y-axis. So that means, okay, so again, if it was reflected over the x-axis, then we would see this. That's a reflect over x. And then this is a reflection over y. And so if we're reflecting over both, that's going to look like that, two negatives, which in this case do not make a positive. They make a double reflection. Function g is a horizontally scaled version of function f. You can figure that one out. Now, moving on to function quiz 2, which I've not done yet. So I may scratch my head a little. It's okay. All right, what is the domain of f? So we know domain and range, right? Domain is the x values. So we want to know all the x values. So I'm thinking, and it's discrete. This is a discrete function versus continuous. So this is discrete. Continuous is like that. Important concepts in calculus. And anyway, the domain is -6, 0, 2, 4, and 7. Do you see that? Those are the y value or the x values of the points on the function. All right. It's discrete, so it's that one. These that one would be for continuous, you know, would be inequalities, and that is the y values. Continuous. What is the value of f inverse of 0? Okay, so first of all, how do we say that? We say f inverse of 0, and we know if x, y, if we have a function and it's x, y, then the inverse is yx. So an example point, if 1, 2 is on the graph of f of x, then 2, 1 would be on the graph of, that is, don't like that, would be on the graph of the inverse. Anyway, so f inverse of 0, that means so that's the y values of the inverse are the x values of the original, and the x values of the original are the y values of the inverse. So this would be x value on the inverse function, it would be a y value on the normal function. This is the normal function, so that where is y 0? Right here. So that has a 0.60, which means the inverse of 60, inverse has a graph of 0, 6. So what is f inverse of 0? It would be 6. Switch it up. So hopefully you did that in algebra 2. What is the inverse function of that? Okay, so when we have to find that, it's a simple process. We write the function with a y value. We switch the x and the y. We solve for y. Multiply by the reciprocal. Multiply by the reciprocal. Okay, so 4/3 x minus 12. So once again, write with y, switch x and y, solve for y, bam, done. All right. So 4/3 x minus 12. That's it. Okay. You can do it. I'm not helping you. Okay, that doesn't count. All right, you can do that one too. Moving right along to some trig. Oh boy, the unit circle. I love the unit circle so much. It was really hard for me in Algebra 2 way back in the day. And then I said to myself, I will learn this thing. Okay, what is the angle theta sub 1? The angle theta sub 1 is located in quadrant 2. And cosine of theta sub 1 equals -2/11. What is the value of sine theta sub 1? Okay, and just so you know, trig is not going away. There's something that it's like the new fractions. Everyone that I know has a little bit of trouble with trig at least. But we know this. We know cosine is our x values, and we know sine is our y values. Okay, and we know we have a triangle. You know, right triangle trigonometry. We know we got SOHCAHTOA. We know that. So let's draw our picture, and we're in the second quadrant, which is right here. And so we're going to draw it like this. And so what's negative in the second quadrant is our x value, but the y is still positive. So that means, oh, and the cosine is 11. It's 11/2. It's adjacent over hypotenuse. And so our vertical side there is unknown. But how can we figure it out? We can use a squared plus b squared equals c squared, of course. So 2 squared plus b squared equals c equals 11 squared, 121, 4. So b squared equals that 117. So b is the square root of 117. Okay, so that's the square root of 117. So the sign would be the square root of 117/11. Express your answer exactly. Well, all right. We're going to give it a try. If we get it wrong, if I get it wrong, it's okay. Never mind about that. I got it right. Okay. Convert the angle radians to degrees. So when we're converting from radians to degrees, we have that conversion factor or multiplier or something, pi over 180, and then we also have 180 over pi. So when do we use what? When we want to add the pi into the number, then that means we're going into radians, which are a fraction of pi, right? So this one is 2 radians, which is that RADS on your calculator that you didn't used to know what that meant. And if we want to cancel out the pi, then we use the one where pi is on the bottom. So we're in radians and we want to go 2 degrees. So we're going to use the 2 degrees one. So 23 pi over 20. And we just multiply them. And as I said, the pi's cancel. What else cancels? These zeros. So we end up with 23 times 18/2. Cancel out that. So I just got to do 23 times 9. So 27, 18, 20, 207. It may be 207 unless I did my math too fast. Goodness, I am getting them right. Okay. Points A, B, and C are plotted on the unit circle. Which of the coordinates is equal to sine of 11 pi over 6? 11 pi over 6 is an exact value. All right, I really want to tell you about the unit circle. Is this my time? I think this is my time to tell you about the unit circle. Okay. So in case you didn't know, unit circle basics. Set up basics. Do radians. We could do degrees, but so the first thing you do is you count by 1/6 and then by 1/4. Then you have all your pi values all around the circle. Then label coordinates using values. So the values are 0, 1/2, square root 2 over 2, square root 3 over 2, and 1. That's it. Those are the only values that we have on the unit circle, just those 5. And they go in that order. And so it's like, you really think about it, we can make it really simple. We can say this is like 0, 1, the square root of 0, the square root of 1, the square root of 2, the square root of 3, and the square root of 4, all over 2. How crazy is that? 0, 1, 2, 3, 4, 2, 2, 2, 2, 2. And so what is this? That ends up being 0, that ends up being 1/2. This we leave as that, this we leave as that, and this is 2 over 2, which is 1. So you can remember those, and we can draw our unit circle. Watch me draw my unit circle so fast. Okay, so I have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 9/6, 10/6, 11/6, and 12/6. And of course, you can reduce those and put a pi on them. But, just to set it up so that you always know where everything is, you can just count 1, 2, 3, 4, all over 6s. Then we do the fourths. So the fourths are in the middle of the 6s, and of course on the axes. So that's 1/4, 2/4 is the same as 3/6. 3/4, 4/4, it's the same as 6/6. 5/4, 6/4 is the same as 9. 7/4, and then 8/4 is same. Okay, so that's how you can set up your radians, and so we can see our measures right there. But the last thing and the most important thing is the coordinates. So our first coordinate is has a long, well, our very first coordinate is 1, 0. Everyone should know that. Of course, 0, 1, and then -1, 0, and then 0, -1. So those should be straightforward. But then going down the line, the next biggest after 1 is √3/2. So that's our next x value. And then this is the first one with a y value. So it's got 1/2. The fourths always have √2/2. This 2/3 pi is going to be 1/2 √3/2. So they just switch places. We already got that one. This one is a reflection of that one. So it's going to be -1/2 √3/2. And then you just kind of use the reflections. That's the 1 plus. So, and you can fill out the rest. So that is how I do the unit circle. I made it super easy for myself the second time I had to learn it. So I know that this is 11 pi over 6. Took no time at all. Oh, and the sign is the y coordinate. Okay, 310. So now we got to talk about that really quickly. I talked about radians. So how do we do degrees? So that's just count, instead of count by 6s, we count by 30s and then 45s. This is for degrees on the unit circle. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Okay, so let me write that 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330. Then let's count by 45s. 45, 90, 135, 180, 270. What? No, that's not right. 225. Then 270, and then that would be 270 plus 45 is going to be 5. Oh, 315. And then 360. So which one is approximately equal to 310? That would be C. And the sign is going to be the y value of C. Again. All right, so that wasn't an exact unit circle value, but you can see what they are. Okay. So now I can easily do these. Oh man, where can I undo that? There we go. Okay, so 150 is right here. And so that's a reflection of 30. And I know 30 was root 3 over 2, 1/2. That's going to be negative root 3 over 2, 1/2. And so that's the cosine, and that's the sine. See that unit circle, really nice. Okay. The sine is 1/2, and the cosine is square root of 3 over 2. And don't try to just memorize the decimals, Sometimes people do that. Now, what did I forget? Do you know? I forgot the negative. There we go. Wow. So much learning, and we still have one more quiz. Welcome to pre-calc. I don't even know if I can do this lesson. I used up all my trig knowledge there. Okay, the interactive widget. Okay, so note that so this is shifting. I might have to pause this one. This is about the frequency and the amplitude and the phase shifting. So kind of like the first quiz we did, but with trig. Okay, so we want to graph that. So this one, look at that. How fun, right? Okay. So I'm gonna pause the video and see what the way that they say to do it, and then come back online here. Okay, this last quiz in trigonometry is going to take some more time. So I am going to add it. Don't worry about that. I'm going to add it to week 4. Okay, so for this week, just do quizzes 1 and 2 in the inverses and composition, and then quiz 1 in trigonometry, and we will do quiz 2 next week. All right, does that sound good?